Okay, so that word positive, that refers to the slope, okay? So when it says strong positive correlation, that has to do with the direction of the line, okay? So if it's a strong positive correlation, okay, there's points that are clustered really, really close together that form almost a straight line if it's a strong positive correlation, and it has a positive slope. So like I said, positive refers to the slope. Strong refers to how much it is a straight line. Because when you're dealing with a scatter plot, those dots are everywhere. So if it's strong, that means it's the close to a line that it can be. So the closer the points are to forming a line, the stronger the correlation. Okay, so as they form more and more and more of a line, it's a stronger correlation. Same thing happens with a strong negative association. If it's a strong negative association, what can you tell me about the slope? It's negative, okay? Because negative refers to the slope. Same thing as positive refers to the slope, okay? And again, the closer the points are to forming a line, the stronger their correlation. So if it's strong, it's going to look a lot like a line. If it's weak, there's going to be dots everywhere. Okay? With a weak association, you cannot make predictions from that type of data. Okay? So if it's weak and it is just points all over the graph, you can't make any prediction of what's going on. Okay? Now, let's talk about these different graphs. Okay? It says which plot seems to have the strongest positive. So if it says positive, what am I looking for? A positive slope. Does that go up or down from left to right? Up from left to right. Which one looks pretty strong? Just shout it out. One. Okay. Two, kind of. Which one's stronger between number 1 and number 2? One. Okay. So that is the strongest positive association. Which plot seems to have the strongest negative association? 5. Okay. It's closer to a straight line, and it's going down. It has a negative slope. Which plot seems to have the weakest association? 3. Everything's scattered. It doesn't look like it's either going up or down. You track with me? Okay. Sounded pretty good. All right. Would you expect each pair of variables below to have a positive, negative, or no correlation? The number of minutes that Grant has been running and the distance he has left to run. He plans on running 3 miles. Let's do it again. The number of miles that he has been running, okay, and the distance he has left to run. Oh, did I say miles? Yeah. Whatever. Okay, the number of minutes. Okay, so let's think about a graph. Okay, is time usually X or Y? X. Okay, so here it is. The number of minutes that he has been running. As that goes up, what happens to the miles? It decreases, right? Because if he keeps running, he's going to get closer and closer and look closer to completing 3 miles. Okay, so if he's up here at 3 miles, the more he keeps running, it's going to go down. He's eventually going to be done with his 3 miles. Does that make sense? Yeah. Okay, so this is a negative correlation. All right, the age of a person and the last digit of their zip code. What do you think? Positive, negative, or no correlation? No correlation. It doesn't matter what their zip code is, right? Those two things just don't mesh. Okay? So if it ever sounds weird like that, it's no correlation. All right, what questions do you have so far? All right. The length of the grass on a baseball field during the summer and the number of days since it was last mowed. What do you think? If it helps you, think about a graph. Yeah. He thinks positive. Anybody else think positive? Anybody else not really sure? Let's talk about it. Okay. So, what is usually X? Time, days. Okay. So this is the number of days. So as the days go up, okay, and it says the length of the grass. So as the days increase, what is going to happen to the length of the graph? It's going to go up, right? Because here it was mode, okay, and then it's going to go up. Okay, so that's a positive correlation. I think the best thing to do is to draw a graph. It just helps you kind of visualize what's going on. The number of phones in a house and the number of people living in the house. Okay, she says no correlation. Think about it this way. In your household, okay, as somebody usually gets to a certain age, do they get a cell phone? Yes. So is there a correlation between the number of people in that house and how many phones there are? Yeah. Okay, because every person is eventually going to get a cell phone, usually. Okay, sometimes we still have some people who are traditional, okay, and they don't have that, but, you know, say that you have 2 people in that household, okay, then guess what? The number of cell phones starts there, and it's going to keep going up. As soon as they have another kid and another kid, at some age, they're going to get a cell phone, so that'll go up, so that's positive as well. All right, so by looking at scatterplots, it's fairly easy to make a decision about the direction. Okay, so it's when you're looking at a scatterplot. So kind of like we did here, let's go back. So kind of like we did here, you can tell if it's positive, negative, or no, right? It's pretty easy to visualize that. Okay. So we're going to put numbers, okay? We're going to put numbers to the strength of a scatterplot. Have you done that before? Okay. So this is something that's new. Okay, and we call it a correlation coefficient, okay, or R value. Correlation coefficient or R value, they're the exact same thing. Usually, I will refer to it as the R value. It just seems to make more sense. But, what if you're on the OST test and they say correlation coefficient, okay? You have to know that they're the same thing. All right, so this R value, it's always between -1 and 1, every single time. It'll never be bigger than -1 or 1, okay? So think about your number line. If I have a number line, -1 to 1, it has to be here, okay? It'll never be on the outside of -1. Now, if data sets that have an R value, if they are close to 1, that is a strong positive association. So the closer they are to +1, they are a strong positive. So if they're close to -1, what are they? It's not weak. Strong negative, yes. Any guesses? Oh, never mind. That's not what I thought it was. Okay. If they are in the middle, okay, if they are at 0, that is a weak association. Okay, so it's a weak association if they are close to 0. But if they're close to 1 or -1, it's strong. You just have to decide positive or negative based on what number they're close to. So here's a really great little chart. Okay, 0, weak. What about 0.1? Is that strong or weak? Weak. It's really close to 0. What about 0.5? It's a positive correlation. It's, you kind of say like semi-strong, right? Not weak, but it's like kind of semi-strong. Okay, and we'll talk more about that. So here's kind of a good reference guide for you when it comes to kind of filling out a chart. All right, so if we look here, okay, match each rank correlation below with the graph. So if we look at 0.1, first of all, is it positive or negative? It's positive. Is it strong or weak? Weak, because it's close to 0. Which one looks positive? Look for positive first. This one's positive, right? What else do you think is positive?
2,
Maybe 2, but could 2 be negative? Yeah. Maybe 3. Maybe you want to skip 0.1 and go to a different one?
Yeah.
Okay, let's narrow some things down. 0.8, strong or weak? Yeah, really close to 1. Is it positive or negative? So positive and strong. Which one's positive and strong?
4.
Right there. Yep, number 4. So I'm going to cross that one out. We're going to put number 4 right here. Okay, now letter C, negative 0.9. Well, obviously it's negative. Is it strong or weak?
Strong.
Very strong. That's really close to negative 1. Which one's a strong positive? Yeah, number 1. Okay, now we got these two left. They're pretty rough. Here's what I would do. I would look, okay, and I would see, okay, are we looking for positive or negatives? Well, 0.5 and 0.1 are both positive. I would look at which one is the least that looks like a line. What do you think? 3. Yeah. Because look at this. Okay? Look at this. If we're talking positive, you can connect there, right? You can almost connect there. So that one is definitely going to be a little bit stronger. Okay? It can get tough sometimes to pick these out. We'll put 3 here. When it gets to those like smaller numbers that are the decimals, it gets tough, but you'll be able to figure it out. All right, which graph shows the strongest correlation? So what tells you that it's the strongest correlation? Number 1, why? Okay, so she said it's negative 0.9. 0.9 is close to 1. Visually, what tells you that it's strong?
It's the one that's
Yes, it's the one that looks closest to looking like a straight line. Oh, we'll put number 1. Looks a lot closer to a straight line. All right, what questions do we have? All right. All right, so now we're talking about actually making a scatter plot. So here we have Kobe's hours of exercise and his weight loss. Where do you want to put hours of exercise? Do we put it on the X or the Y axis? Yeah, okay. If it's time, we're going to put it on X. Okay, weight loss will be Y. Now it says, number 1, label each axis appropriately. Okay, so we're going to put hours down here. Okay, we'll say hours exercised. And then here, this is going to be weight loss. Okay, and we're going to do that in pounds. Okay, when you have that, go ahead and roughly plot each thing from the table here. I'm going to have to write you past. Give me just a second. Right, does yours look a lot like mine? Okay, perfect. All right, so is it positive or negative correlation? It's positive. Is there any point that seems to be unusual? What point seems to be unusual? Yep, 1.3, 0.5. Oops. This guy right here. Okay, that's what we call an outlier. Everybody say outlier. Okay, it lies outside. Outlier. Now, here we go. This is your first R value that you get to estimate. What would you estimate as the R value for this particular scatter plot? What do you think? Okay, she says 0.8, 0.7. Other ideas? It's not. I mean, there's no exact number I'm looking for. I just want your thoughts. Do we agree with 0.8, 0.7?
I say 0.7.
0.7? 0.75? 0.7. Okay. Honestly, you could give me 0.75. You could give me 0.7. As long as I know you're within a couple points, you're going to be fine. Okay, so we'll say r equals 0.7. We know it's positive because the slope is positive. Okay, now if we didn't have that outlier, what number would you have told me? 0.9. That is almost a straight line without that outlier.
There's more than one outlier.
Yes. Yep, you can have more than one outlier, absolutely. Okay, any other questions? All right, let's keep rolling. Okay, Juan wants to rent a house. Okay, he gathers data on many similar houses. The distance from the center of the city is X. Okay, so here's our distance in miles from the city. And monthly rent for each house is on Y. What could the 1,275 represent in context? What do you think? What could 1275 mean in context? Okay, first of all, where is 1275 found? It's on the y-axis. Okay, so if we look, okay, here's 13, so 1275, I don't know, like here. Okay, would you put it all the way out here? No, based on where that data is going, okay, it would go somewhere over here. Okay, now I want you to think about, that's rent. Can we agree on that? Rent is 1,200. Okay. If you pay rent of 1,275 based on this scatter plot, how close are you to the city? Are you very close or are you far away? You're very close to the city. Okay? Looks like here, well, this is like 1 mile away from the city. So is it more expensive to live near the city? Yes. Yes. Okay, it is. So if we look here, the estimated rent for a house in the center of the city. Does that sound okay? Maybe? Right, because it is close to the center. Let's keep reading. The estimated minimum rent for a house far from the center of the city. No, cross it out. The estimated change in rent. Is it the change in rent? No, it's not the change in rent. The estimated change in distance. Is it the change in distance? No. Okay, A was the best answer for that. Prime OST question. Okay. X amount, okay? If you're not sure, X amount. Okay, so when we look at this right here, that's how we decide strong or weak. So the stronger it is, the more it will look like a line. Okay, so if we look at what we had, right here, it was almost a straight line except for this outlier. So if we didn't have this, we said probably about 0.9, but because of that point, we went down to about a 0.7. Does that help a little bit?
Yeah.
Okay.
Very specific correlation.
All right, Bryson. Okay, stay with me. We're about to do a fun activity. Stay with me. Bryson collects data on the depth of a river at various points. The data have a correlation coefficient of negative 0.9382. Which scatter plot do you think represents? Okay, first of all, I want you to tell me which one to cross out because it's definitely not the right answer. Audrey, which one do you want to cross out?
D.
She says D. Why do you say D?
Because that's positive and it's also 3.
Okay, very weak. What else? Kiwi, what else? You want me to cross it out? Okay, why? It's very positive and it's very strong, okay?
And
So just tell me what you think the answer is.
A.
A, okay? Now, who else had their hand up back there? Gavin, tell me why A is the best answer.
Negative is really strong.
Yes, this negative 0.9 is almost negative 1, okay? That shows that it's very strong. It's almost a complete straight line, and the slope is negative on it. All right, I'm gonna let you do this, okay? See if you can match them up. Try to match them up on your own. Do your very best, okay? If there's something you're not sure about, you can leave them blank, okay? Or you can just make your best guess. We'll talk about it here in a second.
These are really bad.
I need a volunteer to tell me their numbers. Okay, Jeremiah, tell me your number here. What'd you put?
-1.
Okay.
-0.7.
Okay.
0.8. 1.
Yes, good job.
-4.
Yes.
0.4.
Yes.
And 0.2.
All right, now I want to know, does anybody disagree with any of these?
No.
Okay, did I hear yes?
Who's like yes?
Okay, what do you disagree with?
The last, the R -4, -0.4.
-0.4? Okay, which one did you have there?
It's not
Yeah, it's generally going down. So that one would be negative.
What about R that also?
So which one did you have as -0.4, Kiwi?
The last one.
Here?
Because I just saw.
Oh, okay.
Because point 2, that's positive, but that looks like it's going down. Yeah. That's both of them.
But could it be going up?
But maybe it's going down. Really bad.
It does look like it's going down.
Not as much as those going down.
Did anybody else do what Kiwi did? Flip those two? No? Okay, I can see why you did. Okay? If I give you a quiz or a test, it's going to be obvious. Okay? If you know what you're doing, it's going to be obvious. I won't make it that time. Okay? If you had that, don't worry about it. Okay? Because I would agree, this one definitely looks negative. But when you get over here, you're like, kind of negative. Okay? So, yeah, that's okay. All right, example 8. Determine whether each of the following has a positive, negative, or no correlation. The temperature at the beach and the number of ice cream cones eaten. Okay? Okay, first. What's X and what's Y?
Temperature is the temperature is Y.
You want to make temp Y?
Yeah.
Okay. Okay. You don't agree?
I don't ask me why.
I'm not sure what I'm thinking.
Don't ask me why. I just think temp was on the bottom. No. But I could be wrong, honestly, but I think you're wrong.
All right, let's just do it this way. Let's do it this way.
My brain isn't functioning.
Okay. It says, as the temperature goes up. I'm sorry. Well, it could say. Okay. Does the temperature at the beach positively affect how many ice cream cones will be eaten?
Yes.
Why?
Because it's hot. People want
It's hot. People want something cold. Okay.
And if it's like
So.
wintertime, no one's not even going to want to go to the beach.
Yeah. Okay. So in general, we would call that positive. Okay. Now, if I was going to put this, I would probably have done temp on the bottom. Just because it came first. That's not always a good rule. Not always a good rule. Okay? But because it says the temperature affects the number of ice cream cones, that's why I say switch up to mine. But, okay, that's okay. Alright, does your age affect the length of your hair?
Yes.
No.
You could be 35 and have short hair. Yeah. But that's
No, baby.
Alright, so my argument for you can do whatever haircut you want is, but when you already hit, your hair grows, right? So it's like the older a baby gets, the more hair it gets. But that's whatever you cut it off.
I mean, but you see it growing like one rate of your hair grows.
So here's my point. Here's my point in this conversation. I love that we have differing opinions. When there's something that you can have differing opinions about, typically it's no correlation. Okay? So typically if you can have differing opinions like, well, sometimes this and sometimes that, it's not correlated. That makes sense?
Yeah.
Huh?
How are we supposed to know that?
My point is that if you can see that there could be different, if you can see. Okay. So this would be no correlation. And this one was positive. All right, this is my favorite part of the day. Are you ready?
Yeah.
This will be fun. Audience participation. Okay? Let's gather some data as a class in order to complete the next scatter plot. Okay? Fill in the table below with an ordered pair. Shoe size and number of siblings. So for example, if I go first, okay, my shoe size is a 9, sometimes an 8.5, okay, but I'll just go with 9. I have one brother. Okay, so my coordinate point is 9, 1. Go ahead and write that in the first box.
I wrote it.
Well, hold on. We're going to go around the room. We're going to collect data. Okay? Andre, I want you to go next. Okay? What's your shoe size? When we get to you, I want you to know your coordinate point. Just tell me blank, comma, blank. Okay?
7.5 over 1.
Okay? Next.
Oh, me? It depends. Do you want like my tennis shoe size?
That's
or
fine.
Like dress shoe, because dress shoe is like smaller.
Tennis shoe.
10.
Comma, what? How many siblings? All right, how many siblings?
Oh, 1.
All right. Well,
Oh.
12, 1.
No, it's
Guys, I cannot hear. Well, 12, 1. Okay. Lydia. 7, 1. Ooh, lots of 1 siblings here. 9, 2. Okay? 10, 1.
5,
5, 4. Ooh.
4. 4 is the best. Yeah, wait. I agree.
7, 1. Guys, you should be writing these down as you go.
7, 4.
7, 4.
You're solid 8.
8, 1.
Uh,
Hello.
8 plus your shoes are inside. You 8.
Next.
9.
9, 1. Miss Mallory Bibler. 11 and a half what? 3. Stop hitting that projector. 7, 2.
Oh, wait, I'm supposed to write this down. Oh, no.
Yeah, you can count yourself. 6 and 2.
Wait, we're not going to skip. No, you can't just skip 8 or 2.
8, 2.
11 and a half.
1. You said?
Yeah.
2,
You wear a size 2.
Yeah.
No, you do not.
Yeah, she does.
Really?
Yeah. Right here. Oh, these are 6s, but my tennis shoes are 2.
Wait, what is it?
I'm gonna put 6.
I was size 2, so.
6 what?
Birthday. No, my tennis shoes is 2. I put 2.
Well, I know, but those are 6. That's a little bit more normal.
Wait, 2 in kids size? Your shoe size? 6 and 1. 2 and what?
Like,
I wear 2 in men. 2 in kids. 2 in kids. Put your foot up. Go like that. Big. I
Okay.
have so much room.
how many siblings?
I have
1. All right, we'll go 2, 1.
That?
Okay.
That's what
Next, Laura.
8 and a half, 9.
8 and a half and 9.
Wait, whoa, 9? 9? Yep.
9 siblings.
Holy
11, 3.
Unless it's like my
12, 6.
25, 10. Yeah. 308.
All right.
2.
2 and 2.
I question every shoe size. Like, I'm questioning
Okay.
8.
8, 1.
I could
All right, and our last one. 9 and a half and 2.
Yeah. I want to add
All right.
I want to add one more. Let's make
I'm going to give you a little bit of time because now you get to plot all of those. Okay? So, what is your x value? What's your x-axis, I should say?
Your feet size.
That is shoe size.
Feet size.
Okay, y is number of siblings. So go ahead and plot all these coordinate points. I'm going to do mine up here as we go here.
Can you do it for me? I'll pay you $5.
I can't even see all of this. How am I supposed to?
I actually don't have $5, sorry. I'll pay you with a hug. I have 30.
No, that's not right.
Wait, what menu that means? You can have a repeat. Oh no, I didn't. Okay, luckily they plugged me. Actually, shit.
He's a soft.
Guys, there should be no talking. You should be plotting and not talking. If there's a repeat, then there's already a dot there. That's okay. All right, do we have a correlation that's positive, negative, or no correlation?
No correlation.
Okay, now I want you to think about it. Should your shoe size affect how many siblings you have?
No.
Doesn't make any sense, right? No, it shouldn't. Okay, is there any point that seems to be unusual?
Yes.
Or did I forget yours?
I'm
The ones with the
You say
two.
Laura?
Laura. 2, 1.
No, you got her.
I plotted something wrong.
No, you didn't. No, you didn't. You got it. Hers is
2 people had a shoe size of 2?
Yes. You plotted it right. You got it right.
Wait, you have shoes?
Can I grab my name down for
Wait. Oh! Who has 2? Oh, okay. I forgot that. Okay.
Yeah, I was.
All right, so we could say 2, 1, 2, 2. But there's one. I don't think that those are that great, honestly. Like, I think those fit more with the graph than this one.
Okay.
Right?
Not my fault.
No. I'm just saying. I'm not saying anything about anybody. I'm saying visually on a graph, this is the outlier. Yes?
Your parents must love
I write my name down for it. They're not all
Okay. We can put. Okay. If she wants us to. All right. Estimate the R value. What do you think?
0.2. I don't know. I don't know. That doesn't look. It looks positive, but it's not starting to.
It's maybe a little bit more positive than negative.
Yeah, I'd say it's a point. So I'd say point 0.2 or 0.3. 0.2 or 0.25.
0.2, 0.25, 0.2, whatever. We're all about pretty close to 0.2.
0.2.
Okay. Is there anything else on there?
Nope.
Good deal. You got about 8 minutes to hang out. Okay. On Monday we will do some more of this stuff.
I have a two for you every day right now.
Your sister a little bit.
See, I